The necessary and the sufficient condition for a bounded function f to be Riemann integral on closed interval ab is that to every epsilon greater than 0, however small, there exists a partition p such that upper bound of partition p function f is minus lower bound partition p function f is less than epsilon. Proof: the condition is necessary. Assume that f is a Riemann integrable on closed interval ab. So integral lower Riemann integral a to b of f of dx is equal to upper Riemann integral a to b of f dx. Let epsilon is greater than 0 be given. So lower Riemann integral a to b f of dx is equal to lower bound least upper bound of lower bound of partition p function f such that p is a partition of closed interval ab. So lower Riemann integral a to b f of dx minus epsilon upon 2 is not a upper bound of the set of the lower sums, which implies there exists a partition p1 of closed interval ab such that lower bound partition p1 function f is greater than Riemann lower integral a to b of f of dx minus epsilon on 2, which implies lower Riemann integral a to b of f of dx is less than lower bound of partition p1 function f plus epsilon upon 2. Equation 2: upper Riemann integral a to b of f of dx is greatest lower bound upper bound of partition p function f such that p is a partition of closed interval ab. So upper Riemann integral a to b of f of dx plus epsilon 2 is not a lower bound of the set of the upper sums, therefore, which implies there exists a partition p2 of closed interval ab such that upper bound of partition p2 function f is less than Riemann upper integral f of dx plus epsilon upon 2. Equation 3: let p is equal to p1 union p2 be the common refinement of partition p1 and p2. So upper bound partition p function f is less than upper bound partition p function f, and lower bound partition p1 function f is less than equal to lower bound partition p function f. Equation 4: from 2, 3 and 4 we get upper bound partition p function f is less than equal to of upper bound partition p2 function f is less than upper Riemann upper integral a to b of f dx plus epsilon upon 2 equals to lower Riemann integral a to b of f of x dx plus epsilon upon 2 less than lower bound partition p1 function f plus epsilon upon 2 plus epsilon upon 2 equals to lower bound partition p1 function f plus epsilon is less than equal to of lower bound lower lpf plus epsilon. So upf is less than lpf plus epsilon. So upper bound partition p function f minus lower bound partition p function f is less than epsilon. So to every given epsilon is greater than 0, however small, there exists a partition p of close interval AB such that upper bound partition P function f minus lower bound partition P function f is less than epsilon. The condition is sufficient, assuming that for every given epsilon greater than 0, however small, there exists a partition P of close interval AB such that upper bound partition P function f minus lower bound partition P function f is less than epsilon. Equation 1. Now Raman upper integral a to b of function f dx is less than equal to upper bound partition P function f less than lower bound partition P function f plus epsilon, because of equation 1 is less than equal to a full lower Raman integral a to b of function f dx plus epsilon, because lower bound partition P function f is less than lower Raman integral a to b. So upper Raman integral a to b f of dx minus lower Raman integral a to b of f dx less than epsilon. Since epsilon is a arbitrary, so upper Raman integral f of dx minus lower upper Raman integral f of dx less than 0, so which implies Raman upper integral a to b of f of dx is less than Raman lower integral a to b of f of dx. But we know that this is equation 2, but we know that lower Raman integral a to b of f of dx is less than equal to upper Raman integral a to b of f of dx. From 2 and 3, this is equation 3, from 2 and 3 we get lower Raman integral a to b f of dx equals to a upper Raman integral f of a to b f of dx. So f is a Raman integral on closed interval a to b.